This is the Amp Hour Podcast, released January 14th, 2018. Episode 375. An interview with Tim Mithro Ansell. Welcome to the Amp Hour. I'm Chris Gamble of Contextual Electronics.
And I'm Tim Mithro Ansell of Too Many Projects to Talk About, but I guess we might start with the Tomu, which is a project
that's the most recent, yeah.
Yeah, and in fact, it's not really my project anymore.
Oh, wow, okay. Well, that makes it easy. So,
yes.
Coming on here talking about other people's projects, I could talk about someone else's project too if you want. I mean,
it basically, I guess, the interesting thing about it is it's something that lots of people are really excited about, but it was something I did pretty much on a weekend.
okay.
And I did it because everybody was telling me that this isn't something that a hobbyist can do. I'm not a professional hardware engineer. I'm a software engineer who likes to dabble with hardware. And because of that, I tend to think I can do things that other people who are hardware and a lot more experienced say, nah, that's not a good thing to do because I don't know better. Mostly that's a bad thing.
That's how you learn, though. That's how you learn.
Yeah.
You know, like either way, either learn, no, they were right, or they were wrong. So yeah, that's great. And this is a common theme with our guest last week, who you also know. So Clifford was on last week.
Yep.
And you also know Clifford. So that's great. It's
yes.
Is this like a thematic of how dare you challenge me to say that I can't do this thing? I will show you.
Yep.
I like it.
And so I should also mention I'm not a security expert.
Okay.
So
me neither.
I do, however, believe that you can only trust what you can see. If you can't see it, you can kind of maybe trust it, maybe. And
so you don't trust me right now because we're just doing audio only.
Well, I can hear you. That's close enough to being seeing.
Okay. Seeing with your ears, yeah.
Yeah.
Yeah. So what kind of software do you do? I mean, so you dabble in hardware. We're definitely going to talk about the Tomu.
Yep.
We're going to talk about some of the other past projects people have probably heard of. But what kind of software day to day are you doing? Is it like high level web stuff or back end type stuff?
I've done a huge wide variety of different types of software. I've done back end stuff. I've done front end stuff. Most recently, I've started playing with tooling things. I'm actually a big believer in Python, the programming language. So much so
we'll get to that too.
Started the PyCon conference here in Australia, and that's absolutely massive. Here now, I think it's like 500-600 people.
That's great. Yeah,
and actually. I think you've had, have you had Damien on here previously?
We've not had Damien on, but we've had Tony from Adafruit talking about MicroPython. So.
Yes. So MicroPython has been actually one of the really big reasons that PyCon AU has grown so substantially is like, I was originally very much there. Somebody proposed Internet of Things track at the PyCon Australia conference, and us as ignorant organisers were very much like, oh, that's going to be a bust. Internet of Things isn't really a thing.
Buzzwords.
Buzzwords, and we had totally missed the MicroPython craze, and so we put them in the small room. That was a total mistake. They were busting out of that room, and the year after we learnt that and put them in the big room. But yeah, especially since Damien's here in Australia, in Melbourne, and PyCon Australia was in Melbourne, so that was kind of a big coincidence.
I've heard that the PyCon Australia is probably the next time I'll get back down to Australia because of that conference.
Yeah, it's in Sydney this year. We've just had the change of year, right? So it's not next year I've been saying for the last 6 months. MicroPython's pretty cool. I think Damien's another one of these people, like he's a physicist, and he did MicroPython because he didn't know he couldn't do MicroPython, right?
Right, yep.
And I would have told him it was impossible to do MicroPython, but he did it, and it's pretty impressive. And in fact, one of the big areas that I'm interested in is FPGAs, and I have a project to allow MicroPython to run on soft cores inside FPGAs.
So we've covered a ton of stuff in just 5 minutes here. Maybe I think we're just I'm gonna take the reins here, Tim. Let's go back to the beginning. How did you get started in all this stuff? Like the standard taking stuff apart story, or went to school for it, or what was your path in?
So back when I was a kid, I actually was a voracious reader, and I read pretty much every book in the library, and had quite a high vocabulary and reading age. This was both really good, but it also hid the fact that I have dyslexia until I was quite late in primary school. And dyslexia is something that if you get some early intervention for, you can actually improve outcomes from that quite a lot. But for me, it was kind of a bit late. I was already past the age where they would like to do interventions. I went to this a psychologist who did the evaluation for dyslexia and stuff, and she had this bright idea that said, there are these things called computers that are coming, and they have this thing called spell check. Just get him to do everything on the computer. The spell check will fix all his spelling for him, and nobody will know the difference. And so my parents took this on board and got me a computer. And
I've never heard that as a solution before. Is that like a generally accepted method these days, or is that?
I don't know. This was like the late 1980s, early 1990s. And yeah, the only problem though is that my parents got me a word processing computer, IBM XT computer, 8088. This did not play games very well, or at all. And again, coming back to this theme of not knowing that you couldn't, I decided that I was going to take the games that ran on all my friends' computers who had like things like Commodore 64s and other computers that were really good at playing games, and I was going to run them on my computer by rewriting them from scratch. Nice. And that's how I got into computers. And at some point, I decided this hardware thing looks fun. I'll give that a go. I'd kind of played with... if you're an Australian, you'll have known about a thing called Dick Smith's Funway into Electronic.
Okay, is that like one of those 99-in-1 or 300-in-1 type of kits?
Yeah, it was like a little kit that let you build like little circuits, like flashes and stuff.
Okay.
But none of my teachers or none of my family were involved in electronics, so I could never make any of these work. And so it wasn't kind of until university where I actually got contact with people who understood electronics that I was able to do any real hardware. But luckily I met a couple of people at Adelaide University who were willing to give this green behind the ears whippersnapper some training on how to do hardware stuff, and that's kind of how I got into hardware in university. Basically because I'd already done most of the software stuff, so had a lot of spare time during university, and so they helped me figure out how to do hardware and learn things like how to program a PIC and those type of things.
Okay, and what time? So, like, was this 90s then? Was the university years?
Early 2000s, I think.
Okay, cool. Yeah,
it was still dial-up modem. I have the pleasure of being the first person to get ADSL in our suburb when ADSL became in Australia. And the Telstra tech who came out to our house was very confused about it being a residential place and not a business.
Like why would you be paying for this kind of thing?
Yes, but my parents wanted their phone line back. So that was how I sold it to them, is that they could make telephone calls while I was on the internet. And so, I owe a lot to my parents for being very forgiving of my, usage of the internet.
Right. I don't miss the days of, parents picking up the phone line and ruining internet sessions. Like, that was always the worst.
Yep. I can still hear that modem scrill.
That's right.
When it connected as well. You can always tell whether you're going to get a good connection by the sound, right? Like,
nice. Yeah.
It would sound a certain way, and you'd know, better disconnect and connect again because you didn't get that, 56K connection.
So this seems like a pretty big jump from the 56K modem days to where you are now. So, like, what was in between? Because we're gonna get back to the Tomu for sure.
Yep.
But it seems like you said, FPGAs and other hardware. So what was your early hardware days?
So I think the first big hardware project that I ever took on was my honors project at university. And for that, I decided I was going to build a telephone exchange.
Oh, okay.
And
like an Asterisk type server kind of thing, but
yes,
probably
definitely like an Asterisk server. I'd been playing with VoIP a little bit, but the problem with the VoIP stuff I've been playing with is that I wanted every telephone in my house to be a separate line, right? So I could call between the front of the house and the back of the house and that type of thing.
Right. Not a party line instead of a party line, you're saying.
Yeah. Right. And however, the cards which gave you like telephone lines were like about $100 each. And if you've done telephone before, you know that telephones aren't actually very high data rate, right? They're like 8 kilobytes per second. And I was looking at what my computer could do, which was like 8 kilobytes per second times 4 bazillion, and going like, this doesn't make any sense.
Right.
Why is this so expensive? And so for my honors project, I built, based around a PIC, which had an inbuilt USB interface, a 8-port telephone exchange that was about a BOM of between $50 and $100, depending on how you counted it. This was back in like 2005-ish, maybe a bit earlier than that. I'm hopeless with dates. That's another thing
that's right.
Dyslexia gives you as order of things is hard.
Right. 5002, right?
Yeah.
Right.
So yeah,
that's just useful for like understanding, I think, around like what kind of tech was out there. Were we into the age of Raspberry Pis and stuff like that, or like just kind of relative, like even circuit board costs, stuff like that. Obviously, in Australia, probably getting stuff there's a little bit more expensive, but overall, same kind of technology available.
Yeah. So I don't think the Raspberry Pi was out yet. When was the Raspberry Pi first?
No, it was like 2010 or something like that.
Yeah, I think this was like 5 or 6 years before Raspberry Pi. Okay. It was well before Arduino as well. Arduino kind of wasn't really a thing there, or maybe it was just starting to become a thing. Definitely the Arduino boards were like $50 at that time. If anybody remembers the early days of Arduino, the Arduinos were very, very expensive.
Right. But also for the same reasons of like, circuit boards more expensive, getting parts and distribution was more expensive. It just, it wasn't as enabled for the maker crowd.
Although at the time, Microchip, and I actually think they still do, had this wonderful program, whereas if you signed up as a student, they would send you samples from their chip line. You got, I think it was like 4 samples from 4 different lines every month.
That's nice.
And they'd ship it to you for free.
It's like a Jam of the Month club, right?
Yeah. And so I got all these PIC chips with various different functionality, like inbuilt Ethernet and inbuilt USB. Just like,
nice.
The first of the month, I'd log into their website and go through and select a bunch of different chips that looked cool and order them. And they just send it to me for free. It was actually pretty awesome, and they actually got I still consider myself a PIC person as opposed to Arduino or anything else for that. So, their marketing worked really well.
They hooked you young.
Yeah.
Yeah, right. Cool. That's great.
Yeah.
And so you had this 8-port phone exchange.
Yep.
And so was that using a certain protocol, or how did that actually communicate to each actual phone?
So it just had a standard RJ12 socket, 8 RJ12 sockets, which then connected to a little daughter board thing that I designed to do all the analog shifting. The hardest part was actually doing the ringer signal. Because the ringer signal, I believe, it's been almost 15 years now or something 10 years since I looked at it, but it's I think 90 volts RMS, very low current, but generating that from the 5 volts I had from the USB, while still being within cost, was really hard.
Right. Yep.
It's very easy to do that if you're willing to pay $10 per port, but when you've got 8 of them, 10 times 8 adds up really quickly, right?
Right. Yep.
And so I had to cut corners wherever I could, and I think that was one of the most interesting learning experiences. Was how do I build this with in the constraints I had? And these were all self-imposed.
Sure.
I was the only one who cared about it costing, cheap. My supervisor didn't really care about that at all. He was just very impressed that I was doing a telephone exchange type thing.
Right. And these were all analog telephones too.
Yes.
Is that right? See, that's not what I expected. I thought you were talking about. So you're talking about doing almost like an old school exchange.
Yes.
I was thinking, because you said VoIP, I thought it was going to be a VoIP type thing.
Well, it had a PIC with a USB on it, and so it appeared as 8 sound cards over the USB. And so
sure.
That was kind of how you connected it to Asterix, which was the VoIP thing at the time.
Okay. So this was just the what I'm really thinking of is the you know how the VoIP phones these days are Ethernet based, and they're actually doing it all digital up to the phone.
Yeah.
But okay.
Yeah, no,
that's
this
great.
was
That's
all
really cool.
analog stuff. And so, yeah.
Cool.
And so that was kind of my first big hardware project that I did. And I was actually really happy with that. I had to do some cool hacks to make... I was using a codec for doing the telephone side. The codec did I2S, and the PIC doesn't have native I2S. And so I had to connect the I2C UART to the the I2S bus, and do a couple of bit banging for a couple of other pins to make it all work. And it was kind of this interesting... again, nobody told me that I couldn't do this, and so again, I tried to do it, and I actually did succeed. It took me many late nights in the lab with the oscilloscope trying to get it to work because I had I think I had like 8 instructions that to meet timing on this, and so it was a juggling act of moving things around to try and get it working. But
that's a good question too. So this was all assembly?
Yes, all the PIC code was in assembly. I couldn't afford the PIC C code compiler at the time.
Right.
And there was no open source SDCC or something like that I knew of at the time. Maybe it existed, but I definitely didn't know about it at the time.
Right.
And so, yeah.
So obviously a lot of interest in hardware at this point. So why the switch back to software? So it was kind of like the software jobs were paying out of school, or why did you bounce out of hardware? Or did you not bounce out of hardware?
So I've always kind of been hardware adjacent in some way. But
yeah.
I'm a software person at heart, really. Like, if anybody comes and looks at one of my hardware projects, they'll see I'm a software guy. Like, any person who's a hardware person, like, I want things like unit tests for my schematics. And that's actually another one of these projects that I would love to get going that I've just never had the time to, is to extend KiCad to do much better design rule checks than just like, is this input or output and these voltage levels matches? Like, I would actually like to do real checking that you've got like analog signals connected to analog pins and digital signals, like your I2C bus is connected to the I2C on the device, right? Like many devices have these muxes that let you change what pin functions in which way.
Oh, right. But yeah, like you could have like 8 different, the SPI pins are crossing over the digital I/O or crossing over the serial, whatever. Yeah, right.
Yeah, but frequently they're not a full matrix, right? You can only have SPI on like pin 1, 10, and 12.
Right.
And so it can be really easy to stuff up your design by thinking you've put SPI on like 8, and it turns out you can't map SPI to 8.
Right.
So I want unit.
See, that really gets me on FPGA. We'll get to FPGAs obviously, but like that always gets me on FPGAs when they lock some of those pins out too. It's like, come on, like literally the entire idea of this is to be flexible, and like there's certain things where it's like, nope, you can't do that. And it's never like the top of the data sheet either. That's the other crazy thing. You'd think it'd be like, here's what you absolutely must do no matter what, or else you will mess up your design. And yet that's not how they write data sheets.
Yep.
So, oh well. So how would it work with, so unit testing in KiCad would be, to be honest, I don't even do the ins and outs stuff. I just ignore all that stuff.
Yeah, most people do because it's not particularly useful, but...
right, yeah.
Like, all it takes is one person to describe the capabilities of the part, like, this part is an I2C interface on these pins, and then you could do something as simple as check that I2C interface is connected to I2C interface, or actually coming back to FPGAs, the Spartan 6 from Xilex has this weird thing that HDMI inputs can only be handled on certain banks of the FPGA, whereas outputs can be only handled on other banks.
Right, yep.
And so if the KiCad knew that this was a HDMI system, then it could check that you've connected HDMI to the right banks on your FPGA. And so when you're swapping all your pins around to make your PCB routing easier, you could then run your check and make sure that you haven't, screwed up all your requirements, because the actual tool understands that, these type of pins can only do this type of functionality. or this type of speed is another one, or this is a differential pair is another thing. Like the make sure your differential pairs are matched and that type of stuff. So
see, my thing is always that a lot of that depends on the idea of like part libraries as like software libraries, but that's never really the case because I'm always making my own parts anyways, and so that's like a systemic level type problem as well.
Yeah, and I think it's because part libraries don't really offer you much value these days, right? Like, it's just the footprint. I could create the footprint, and then I know the footprint is correct, right? There's no other extra value that library is providing.
I think you hit it on the head there with it's correct, right? That's like a trust piece, and like I don't trust you, I don't trust me, I don't trust anyone, you know.
Yeah,
but also I don't trust me for the right reasons because I've gotten it wrong in the past, you know.
Yes, but if your library came with a lot more functionality or features, it then starts becoming a value proposition. Well,
burden.
I should use I should use this library because it has all these annotations already in it, and it automatically checks that my design is actually, you know, correct and will work.
Sure.
And
sure.
One thing being a software guy is I hate the iteration cycle of hardware. Like,
right.
Even if you have a mill in your like room, right, the iteration cycle is still hours at best. And
right. If you're really good at prototyping and your parts are capable, if you're not using BGAs, if you're not using TQFPs or anything like that.
Yeah, if you're not using anything useful, like
or modern, let's say modern, right?
Yeah. And so like I don't understand it. Like software, we have an iteration cycle of, you know, seconds mainly, and yet we do all this huge amount of testing to make sure that our software is correct. But like on the hardware side, you have iteration cycle of, you know, weeks or months to get
days,
your PCB back from like, if you're like me, a hobbyist, like in Australia, like Australia shipping takes forever. So like iteration cycles on months, yet we do so little testing beforehand. And that's an area I think that one day somebody will crack. I don't think I will, but it's something I'd love to see somebody work on more, is this kind of whole, let's take this software approach and apply it to hardware. Let's do checks. So every time I commit something, it tells me, hey, wait a sec, your schematic's broken. It's not going to work. You've connected this thing. If you try and make it, it will like blow up. That's a much better than when you put all the parts on it and it explodes.
Yeah, I just think that stuff doesn't change all that much either. That's the other problem, is that like with hardware, it's like once it's done, it usually stays like that for a while. Whereas software, you need those checks because you're changing so many of the underlying pieces that if you didn't have the checks, you would blow up everything all the time because you're always kind of refactoring and, you know, rewriting libraries and whatever else. So you need those unit tests for sure. Whereas hardware, it's like, all right, the interface is done. Don't touch it till the next rev.
Yeah, and that, like, as I said, I do a lot of FPGA stuff, and that frustrates me with FPGA designers so much. Is like, they design something in FPGA, and then it's like, it works, we don't touch it. And it's like, but I want to add features and like fix bugs.
Yeah, tinker with it.
Yeah, make it use less resources and make it faster and do all these type of things. I'm sure there's other FPGA designers out there listening right now being like, you know why we don't change these things, Tim? Is because of the software people. That's the thing, though. It sounds like you're writing the whole stack, right? So you're doing FPGA stuff and then writing software on top of it. You had mentioned before that you're doing like MicroPython on some of these FPGA cores, right? So if you control the whole stack, it's less of a problem than if you're throwing it over the wall to the software people and they're like, don't change anything, I need to write software for the existing register set. Yeah, and if you've got a poor method of communicating your register set, then like it's both the hardware and the software guy's fault, right? Like,
sure,
the software guy shouldn't care where in memory your register is, right? They should just write this, call this function or some type of indirection, or like if you think about modern ARM processors, there's things like device tree that just describe where your things are, and like it doesn't matter if the next version of your chip has the register in a totally different location. If the device tree tells you where that location is, it just works. You don't need to, you can iterate. And that's something...
Great in theory.
Yes.
I think that's the thing. Like, you're talking about changing workflows of different people, and like, I think that you're totally right. But yeah, this good luck in an organizational standpoint.
Well, I think the thing is that once you can iterate fast, it's hard to go back to not iterating fast. And
yeah, I agree with that.
Like, once hardware people realize that, hey, wait a sec, I can change my PCB at any time and everything still continues to work. Like, that's the big thing, is like every time you change something, you're afraid it won't work, right?
Oh, no. That's not why I prevent changes to my stuff. It's because of the cost and because of the hassle of actually building the thing. That's the real problem.
I would say that, why is it so costly to change things?
Because FPGAs are expensive, and part placement cost is expensive, and the logistics of shipping things is expensive. I mean, things are dropping in price, but the problem hasn't gotten any simpler on the assembly side of things.
I don't know. I haven't done many major assembly projects, and I definitely haven't done a project with 10,000 units. But if you look at what, say, Tesla's doing with their cars, how they are effectively starting to go with rolling revisions, and you just have a new car with a new set of features. It doesn't matter when you buy it. I think that's going to happen everywhere. This idea of...
Well, I don't think so, but maybe if it's good enough, like the companies that do it will survive, and the companies that can't or won't do it won't survive. But I boy, that's an optimistic viewpoint, Tim, I gotta say.
It probably is.
Having been around hardware people, they don't even like changing like the color of their pants on between like decades, like
yeah.
So,
but I do think software's kind of eating everything, and
I totally agree with that.
It will eventually come for hardware. There's no doubt about that.
I totally agree with that too. Yes,
it might be 5 years from now. It might be 30 years from now. I don't know. But I'm looking forward to it. Because
I think that's actually a good bit of optimism, and I would agree with that. I mean, like, so I remember like tracking in manufacturing. I used to do it where we would have a problem where like, oh well, this new batch of capacitors was giving us issues because of tolerance stuff, right? So just some random problem, and it's like, oh well, how do we track which capacitor reels was used there? And it's like, we don't track that. It wasn't actually tracked all the way back through the system. If you think about that in a software context, of course you would know. Like you'd be able to go back through the repo, see, oh well, Tim changed the code on this one library at this point. We can go back and revert that or check it or whatever. But I didn't even have any of that data for with the hardware piece of like, oh well, the capacitor reel just changed. So how do the infrastructure wasn't in place. That's what I'm trying to say.
Yeah, and it will be a long time before it's everywhere, but I do think it's a big thing that's coming, is like being able to understand things like this. Or like, if you imagine, I remember back 10 years ago, there was this like bad batch of capacitors that was causing everybody's motherboards to explode. Do you remember that kind of thing? I feel like that we should have been able to understand whose motherboard is going to be able to explode, because we should be able to track where those capacitors were placed on which parts and all that type of thing.
Right. But and then the unit test of, did the board explode?
Yes, that would go no. But yeah,
Okay, cool. Well, let's talk about your FPGA project, because this is probably what people know you for, among other things, right? The HDMI to USB, or is it? Or am I getting these backwards? So I know there's two things here, right?
Yep.
So Tim Videos, is that the same stuff?
Yeah. So Tim Videos is, I guess, the overarching project. It's a project that is trying to build software and hardware to record conferences and user groups, and the HDMI USB is basically the first, or like one of the major hardware pieces that are involved in that. And so, like, HDMI to USB is a Tim Videos project, but it can be used outside of the Tim Videos ecosystem. If you just want to use the HDMI to USB with Google Hangouts, for example, then that's quite capable when you can do that.
So I first came across it when I was looking for my home video setup. People have watched any of my stuff about how I do my videos. I do it all with webcams.
Yep.
And people were also talking about, well, you could do it with, HDMI capture type stuff, and then, streaming it to an OBS or whatever.
Yep.
And someone at some point had recommended your stuff. So it kind of fits in that as well, of like streaming multiple cameras, multiple inputs to a device, and then capturing on a computer. Is that a decent explanation?
Yeah. The kind of environment, though, that we're targeting is user groups and conferences, especially open source conferences, which is a very different position to be in than a setup where you can kind of leave it installed and have it like working and then don't touch it. I guess it's kind of exactly what we were talking about previously, is like with a conference, for example, like the linux.conf.au is a conference that we record regularly and is coming up in a couple of weeks. We frequently don't get access to the venue until the day before the event. That's like on a good thing. Sometimes it's like the morning of the event we get access to it.
They're like, no, there was a wedding here the night before, or there was an event the week before, and they're like, yeah, you get here when you get here. You only paid for 3 days. You only get 3 days.
Yep.
It's fun.
And so, like, we have a very short time to deploy, and then to make things worse, everybody who's operating this is normally a volunteer. And they may have only had like an hour or maybe 2 hours of training on how to use this stuff. Because like none of these conferences really have a huge amount of budget. And if they were paying like a professional coding for this, they would be, ticket prices would be like substantially more. And so one of the things we really need, and this is why we ended up doing our own hardware, is what I guess I call extreme debuggability. The ability to understand why something is broken, not just that it's broken. And a really good example of this is some people, for some reason, like having black backgrounds on their laptop. And it turns out it's very hard to tell the difference between the projector is projecting nothing and the projector is projecting the presentation from the user, but it's just black, right?
Right. Yep.
Visually, a human eye cannot tell the difference very easily. Whereas the computer or the hardware knows whether or not it's getting a signal, right? It knows it's getting a black signal. It can tell you this. And we were just not able to buy commercial hardware that would give us that type of information, that, yes, the person is sending a signal and it's perfectly valid. It's just black. It's working. You tell the presenter to drag something onto that that thing, it's actually working. Please continue. Rather than running around headless going, why isn't this working? You really want that type of information. Or like another thing we can detect quite easily is bad cables. Because we get the way HDMI kind of works is that there are 3 channels, one for red, green, blue, and then there's a clock. If you get errors on one channel, we can actually see that because we keep an error count for each channel independently. And so with this, we've actually been able to see cables where, for example, just the red channel is a bit dodgy and is having like 1 or 2% errors, which is what's causing the like output to flicker in some way. And we can see that. We can actually like debug that and understand what's going on rather than just going, well, it could be the cable or it could be the presenter's laptop or it could be, you know, something else going on.
Right. So just having like small flags of things, like hints, really, right?
Yeah, having details of what's going on. Like,
right. Well, and I would think another thing, too. So like this seems like relatively low cost to some of the commercial stuff you mentioned. Just having more places you can do, you know, you can do small conference sessions then. You know, I've been to like DEF CON and they do professional filming there. But you only can see like 2 or 3 of the stages, I think, on the recordings. And then you have to pay a bunch for them anyways, right? Yeah. So it's like, in this case, you could have a small, you know, a 30-person session and still film it potentially.
Yeah, that's like our eventual goal is I want anybody, anywhere, to be able to live stream and record their proceedings without having to be AV expert. Like,
right.
The only way at the moment we make conferences work is by having people who are experts on like the audio-visual stuff and know how to fix various problems. And the reason they can do this is because they're in their head, there's a whole bunch of knowledge about, oh, I've seen this problem before, I know how to fix that one.
Right, exactly. Yeah.
But with this kind of really advanced debugging information, we should be able to walk through a person who has no AV knowledge about what's gone wrong. Like, a classic example is the presenter plugs into the wrong plug. And so back a long time ago, I originally tried to take the system that we used to record conferences and put it in a box that I could give to someone. And this had like a really nice wizard that would walk you through like setting up the presenter and setting up the audio and checking the levels and all this type of thing. And basically just followed exactly what it said. The problem I ran into is that there are 2 ports on it, and I color coded one red and one yellow, but I couldn't tell when the person, despite me saying please plug into the yellow port, had plugged into the red port. Whereas now we can.
Right.
We can say,
right.
Oh, I meant the other yellow port,
right,
or the other red port type thing, and we can actually like build a system that helps you figure out what's going on and why it's broken and solve that for you without having to have you involved in it.
So what is it? What is the hardware on there that's enabling all this stuff?
So it's an FPGA. Like the big thing that makes this all possible is because it's an FPGA, it's reconfigurable, and we can continue to improve it.
Which FPGA is it?
The current board we're using has a Spartan 6 on it.
Okay.
But it's likely we'll have some RTX 7 based stuff in the near future.
Okay.
But the important part is like when we see an issue, we can debug what's going on. We can add new hooks into the system to allow us to understand what this problem is and prevent it from happening again next time. We can continually improve the HDMI core with workarounds for various, broken pieces of hardware or stupid things like a projector being 1024 by 768, but 16 by 10 resolution, like using non-square pixels and things like that. We can kind of...
Sounds like you're really optimizing for a lot of user error here, I gotta say.
Well,
I know that there's like a balance point of like, well, you don't want to make it easy for the person, but it sounds like you're almost like babying the person. Not babying, that's the wrong term, but like that they're getting an easy way out. Does that sound right or no? Well, there's a lot of technical solutions to what could be a little bit of user knowledge would help, but I guess it's based on the idea that you said most people won't have any training.
Yeah, and it's also like a lot of the problems aren't something that a user can really do things about unless you can tell them exactly what the problem is, right? Like, a user can't replace the cable unless you tell them that it's the cable that's dodgy, right? If you say, oh, the problem could be your laptop, the cable, this other cable over here, this other random thing, right? You just kind of got no hope. And like, I'm sure we've all had this problem where like the presenter gets up in front of everybody and then spends like 5-10 minutes getting their laptop to show up onto the projector, right? That is still not an uncommon thing to occur at conferences. And it just boggles my mind that this still happens. And the reason it's happening is because people solve this problem once for the room that's in, and it never gets shared. It never gets propagated to other people, or it's locked up in somebody's head, and they know that you just have to jiggle this thing in this way to make it work.
Right. And that's usually how it goes, too. It's like, oh, we'll just do it all over again. Plug it all back in.
Yeah, and so I want to move all that into the software, because software doesn't have a, like, imperfect memory and forgets, and it can improve continually, right? Like, hopefully, software can also...
say, bitrot's real, man. Bitrot is real.
Yeah, but actively maintained software should continually get better in theory.
Right.
But because that's the other thing is like, and a perfect example of this is like our Spartan 6 board can only do 720p 60. So if a presenter somehow manages to send 1080p 60 to it, we cannot decode that signal. We advertise to the presenter that the only resolution that we support is 720p 60. So, like, firstly, it's a miracle that they've managed to get 1080p, but, let's just assume they have. And we have seen cases like this. Even though we can't decode that, we can decode the pixel clock, and we can see that the pixel clock is running at twice the frequency that we can decode at, and we can provide a useful error message rather than just going, nope, no data. And that's because we could put a frequency counter on the pixel clock, even though that's not something you could change in your HDMI decoder IC after fact, right?
Like some commercial or some commercial level chip that's just doing that one thing. It's not going to be flexible enough to add a new feature like that.
Yeah, and there's a whole bunch of other features like that we've gone, well, it's really hard to figure out what the hell's going on here. Let's add a feature that lets us understand what's going on here. And as things go forward, we kind of add new features that help us better understand problems and hopefully fix problems with hardware so that eventually you can get to the state that you just plug in and it works, right? That's the goal. Is eventually you just get up there, you plug in, it works, and you don't spend 10 minutes figuring out whether or not your laptop will work. And that's kind of the goal of the project.
Cool. So how did you get to this point of? I mean, this is obviously a pretty advanced project. So the FPGA stuff. What made you choose the FPGA in the first place? And like, how did you start on the process of making this board?
So one of the guests you've had on here, I believe, is Bunny, famous for like Xbox hacking, the Novena, and those type of things. He created a product called the NETV. I forget when he created this. It was quite a while ago. He demonstrated this as a it allowed you to put an overlay over an encrypted HDMI stream. And I looked at that, and his device was deliberately designed to not allow you to do capture, because that would be violating the decryption legal thingy, DMCA stuff.
Of course. Right. So there was like no real complaint against it. I remember when that came out. So,
but I looked at that and went, I think I can make that do capture. However, I wasn't interested in the Bunny was very interested in HDMI, HDCP video. I'm only interested in unencrypted things that I'm supposed to be able to capture, right? I am interested in recording conferences and user groups. If a person is playing something that is encrypted, like the fact it doesn't work is actually good for us because it means we don't get a copyright strike on YouTube.
Right, exactly.
But yeah, that I looked at that and was like, yeah, I think I can make this do capture. And then at the time, I didn't have much time, but I'm lucky enough that I work in IT and I get paid quite a good salary, and I have very few expenses. And so I thought, why don't I just hire someone to develop this for me and see if they could get it to work. And so I went on, I think it was a place called VWorker at the time, like one of these freelancing
like an Elance
sites.
or whatever they're called these days. Yeah, I know what you're talking about. Yeah. Okay.
Went on there and basically wrote up a specification for the type of thing I was after, and found a student in London who was doing a PhD, who was interested in doing the project and wanted to make a little bit of extra cash, and told them what I was trying to do, and they thought they could do it, and that's kind of how this HDMI capture hardware started.
And that is the only recorded instance of that ever working. Sorry, I just had to make the joke. I've seen a lot of people who are like, I have a budget of $20, and I know this isn't you. I have a budget of $20, and I want to make a supercomputer. Who can do this?
Yeah, I think the big advantages I have is I'm a software engineer. I can evaluate somebody's software engineering capabilities. We had an existing thing that almost worked. We just wanted to change it slightly, and I was very upfront that this would be a collaboration type project, and it took me a couple attempts to actually get to a stage of getting something. It didn't just kind of, it's kind of that overnight success. It took me 5 years to do this overnight success type thing.
Right.
But yeah, once I found the right person who was interested, it kind of worked pretty well.
That's great.
But it took me a while to find that.
What were you speccing in? Did you basically tell them to look at the NETV? Is it like a kind of fork of the NETV, or? Originally,
that was the idea. Okay. But it turns out that this group of FPGA FPGA dev board manufacturers called Digilant.
Yeah, we've had Clint Cole on the show, founder of Digilant.
Ah, cool. I've never actually met anyone in person from them, but they developed a dev board called the Atlas, and the Atlas turned out to already have everything we need hardware-wise. It had two HDMI inputs, it had two HDMI outputs, and it had a high-speed USB connector on it. And so at that point, we just decided to, I guess if you're a startup, you'd say you pivot and use that board instead, rather than trying to adapt the NETV to the NETV. And that was kind of like a really good idea because it would have taken, like, the NETV was specifically designed to make what I wanted to do hard, right?
Right, right, of course.
And so
it got you in the ballpark, but then you kind of look at the specs more. That makes sense. So what about the what about cost though? I mean, like FPGAs aren't known for being particularly low cost. So what is the rough cost of these boards, and like, you know, how much did you end up having to struggle with that part of it?
So the Atlas board was definitely more expensive than I would have liked. But at that time, we were using these things called Canopsis twin packs for VGA capture. And these things were like rock solid, but they cost about $500 each anyway. So it turns out that FPGA dev board is in that kind of price range, so it wasn't such a big step up to go to an FPGA instead. And as well, I can kind of subsidize this a little bit with my income from my employment. I don't need to make money, which is very free.
Sure, I
right?
get it. You can be closer to the lower margin overall, you're saying. Yeah, yes. I get that.
I don't have to... all the NRE... I don't have to care about because I'm not in it to turn a profit at the end, and so
right. Well, I just think I always think it's good to call that out though too.
Yeah.
Because if a lot of our listeners, they look at a project like, oh well, why can this project do it and I can't? And I always kind of push back on projects that hide the cost because not push back, that's the wrong word, but it's like, I just want to highlight it because it's like, well, like when someone goes to build the next thing and they're like, I can't get this BOM under $600 now. It's like, well, here is the constraints that led to that. You just kind of need to call that out sometimes for more people coming into the hardware space. That's what I really mean.
Definitely, I'm in a very privileged position. Like, I'm in a very high-paying job. I don't have any costs, any major expenses. And so I have this kind of pool of money that I can use to enable people to do cool things. And as well, all the stuff I do is open source. And so like all the designs are up on GitHub. All the firmware is available. And so hopefully the idea is that the next board somebody does, they don't have to, they'll have some NRE, but they don't have to start from scratch again, which is this other thing in hardware that totally blows my mind is that the amount of time people start from scratch or take something that used to work and change it slightly, but never contribute back to the original thing and make the original thing better as well.
Right.
And so that's something...
Right, well, we've talked about that a ton on here. A lot of that is, not having open standards on the schematic and the layout side of things and, parts changing over time and just lack of openness. So I think, software is definitely ahead in that regard. Yep.
And I'm trying to help there by... because I don't have a lot of time, but I do have this kind of, I have access to money. And so what I try and do is if there's somebody contributing to my project who is struggling because they don't have access to the hardware, and they've made a reasonable commitment to my project, I will just send them hardware. Like, that's kind of the deal I make with my contributors. If you're contributing to my project and you need hardware, I will figure out a way to... Right? You're helping me, so I should help you. And, like, you might be time-rich but financially poor type thing, and let's work together and, like, solve this problem.
Sure. So why in this board are there only two HDMI inputs instead of... So it's 2 in and 2 out, right?
Yeah.
Why only 2? Because I can imagine having multiple camera angles.
So in a small user group type case, the 2 inputs, you would use one board in a room, and one input would be a camera, one input would be the presenter's laptop. And that's just a way to keep costs down. In a conference situation, we actually generally use 2 boards per room. And we have one board up the front where the presenter's laptop is going into it, and normally some type of, like, feed from something like a Raspberry Pi or something like that that says, like, welcome to PyCon, the next thing in this room will be, you know, that type of thing. And then up the back, we have a camera going into a board, or maybe a camera going into an SDI capture card. And then that's all converted to Ethernet and trunked to a software mixing solution, which will then mix these incoming streams over Ethernet. And so that's kind of obviously a much more advanced setup than like the single user group, where you just have one board and you're just capturing exactly what's coming up the USB and sending that to something like YouTube. And I've got diagrams on the website of various different ways you can configure this. But at a conference, we kind of generally the camera and the presenter at like opposite ends of a lecture theatre. And so we don't want to run long HDMI cables like that. HDMI
I think they're limited to only like 30 feet usually, or 10 meters, right?
Yeah, and they have no type of error correction or any of this type of thing in it. Whereas, you know, Ethernet does, you know, hundreds of meters of fine. It has error correction and like gigabit. Every laptop on the sun supports gigabit these days. So, like,
that's great. And plus, you're not worried about, like, interference stuff from Wi-Fi or anything like that. It's just point-to-point into a router or a switch or something. Yeah. So that's great.
So in, like, a big conference, we will generally convert everything to Ethernet as soon as possible.
Yep.
And then we use software. Because we can iterate on software much faster than we can iterate on hardware. So
no, I think that's good, and that's kind of akin to a lot of like DSP type stuff these days too, right? It's like you maybe have a front end for an audio thing, but then you immediately put it into a to D, get into a digital signal, and then you could start doing lots of stuff on it.
Yep.
The only downside that I ever see is latency stuff, just because processing on in digital usually you start chunking on something, it's gonna take a little bit longer, but the cost is usually so low it's way worth it.
Yeah, and on audio, like, on video, if you compare things to audio, you've got, like, an eternity, like, 1 frame per, like, 1/30th of a second. Like, that's a long time, 33 milliseconds worth of stuff. In audio, you can hear that if that gets out of sync, but in video, like, 1 frame latency is not a big problem.
Right. Sometimes it's 1/24th, right?
Yeah.
if it's true film, yeah.
Yeah.
So you switched over. So then Numato Apsis. I'm not sure if I'm saying that right. That's an open source version of this.
Yes. Basically, the Atlas was a great dev board, but it just isn't designed to be deployed anywhere. And so I went on basically an attempt to create a version of that board which better suited our needs and better had the type of features and functionality that we cared about in a configuration that we cared about. You might notice that as many of the ports on the OPSIS board are on the front of the board, right? Whereas on the Atlas, they're kind of all around the board, which makes sense when it's a dev board, right? But if you're trying to rack mount something, you want all the ports facing out like the front and back of the thing. You don't want trying to run cables around corners and that type of thing.
Right. And HDMI cables usually aren't very forgiving on bends.
Yes.
Nice rugged cables.
And so, and one of the best decisions I ever made with the OPSIS board is that I decided to make it the same form factor as the mini ITX like PC form factor. Which means
nice.
that
so you can co-opt the cases, huh?
Yeah. If you want a fancy, like, aluminium case that's all fancy looking, then you can get one. If you want, like, a cheap pressed metal thing that's rack mountable, you can get that, and anything in between. And, like,
that's great.
We didn't have to do any of that design. We just have to do a little faceplate, and then we can reuse, like, the massive PC existing PC industry. We could never make cases for as cheap as they make it for PC stuff, because there's just, like, their volume is, massive.
So this was just kind of an add-on. So this was basically just an open version of it, crowdfunded as well.
Yep.
Looks like it hit its goal pretty well. So that's great. Okay. And so this is still at 720p, 60 frames.
It can do.
It's going to be updated.
720p at 60 or 1080p at 30. It can't do the magical 1080p 60, which is kind of the golden full HD standard. And that's a limitation of the I/O on the Spartan 6.
Got it.
The RTX 7 boards can do 1080p 60 on the I/O pins, and I've been trying to do basically a new board that is based around RTX 7, and it turns out that there's somebody else who was trying to do a new board based around the RTX 7 because they were frustrated with the same limitations that I was frustrated with on the Spartan 6, and that was Bunny. He wanted to do a new version of the NE TV2. So he developed a thing called the NE TV2, and he was showing it off at the Computer Chaos Congress. I can never remember what all the C's stand for, but you know.
Chaos Computer. Wait, is it the Chaos Computer Chaos? Is that what it is? I know it's Triple C, but yeah.
Yeah, I can never remember what all the C's stand for. But yeah, he was showing that off, and
this year or past years?
Last year. So the year before last year. And so I was giving a talk on trying to demystify hardware decoding of HDMI to try and a lot of people think that hardware is kind of scary, and especially like FPGA stuff is scary, and they look at like a HDMI thing and go, wow, this is something that I could never do. And I think that if you put in the effort, most people could actually do this reasonably easy. We're just terrible at teaching and explaining this stuff. And so I was giving a talk that was aiming to kind of demystify that somehow I magically read a specification and came up with a perfectly working thing out of the box with no problems, you know, just like that overnight success that took 10 years type thing. I wanted to show that people could do this themselves, and that, no, that diagram that is confusing in the specification, that confused me too. And I went down all these wrong paths as well. It's not unusual for you to take multiple attempts to make this work. And I wanted to tell people that, yeah, it's okay. This is something that's going to take you a couple of attempts to get right. And here's all the ways I failed, so that you shouldn't feel bad about failing this way as well.
Right. So this was the dissecting HDMI.
Yep.
Okay, great.
That they have a diagram in the spec which was written by a hardware person, because it describes exactly in how you would decode HDMI in hardware in the technology that HDMI, when HDMI was first developed. And it's actually a really simple 3-step process, but this diagram makes it totally incomprehensible. Anyway, I've totally gotten off topic. I was at the conference because I was giving this talk, and then I went and had a chat to Bunny and chatted to him about his NETV2 project, and showed that I could get our firmware that runs on HDMI to USB running on his NETV2. And he thought that was pretty cool. And so we started chatting about that, and have started collaborating on the NETV2 stuff. Obviously, I'm very interested in having an RTX 7 based board, and he's also very interested in that. And so we're just at the last one, the last CCC, 2 weeks ago now, I think.
Yeah. Yep.
We were there hacking on the V2 of the V2 board. And so hopefully he will have something, I don't know, in the next 6 months that will hopefully be compatible with the firmware that we develop. And so that's kind of been really cool, because his NETV1 kind of inspired a lot of where this project came from, and now he's able to benefit from the expertise and code and all the stuff we've done, built on from his inspiration. And so, I feel like this is a really great example of why open source is awesome.
Yeah, definitely. So speaking of Bunny, so Bunny's firmware partner is Sean Zobs Cross.
Yep.
And so he is tied back to one of the other projects. So let's go to that.
Yeah. So that's the Tomu project. So
we didn't get this quite at the top, but what is it?
So the Tomu is basically an ARM microprocessor that fits inside your USB port. And I mean,
but why?
Literally inside your USB port.
Sure.
If you imagine the USB connector, if you cut off everything that's outside your port, and the first reason is because people said that you couldn't make something this size as a hobbyist.
Got it.
The second reason is because there's a group called Ubico that make two-factor authentication devices.
Right. The YubiKey.
Yes, and so they have a thing called the YubiKey Nano that fits inside your USB port, and the idea is that you put one in every computer that you own, and it provides protection against phishing on because it will only respond to the correct sites and all this type of thing.
Yep.
And so I was like, that's pretty cool. My work gives me one for every computer I have, and I was like, my parents and family would be, it would be really good for them to be protected as well. And I looked at this device, there's not much to it, and thought, how much could they cost? And then I went to Amazon and was like, okay, how many do I need? I need about 10 to cover all the computers in my family's house, and looked at it and went, holy crap, that's going to cost me like $1,000. And I love my family, but I don't love them that much. Not like $1,000.
Can you put a price on love? Apparently you can.
Yeah. Well, it's just like a extra.
No, you're just saying it's not worth the cost does not match with the intrinsic value. You're saying.
Yeah, and then the more I investigated it, the more I came to the conclusion that the YubiKeys are like security through obscurity. At some point in the past, they were open, but all their new stuff is all closed. You have no access to what's running on that key. Like, there could be backdoors galore in there, and we would never know.
Right.
And as I kind of said at the beginning, is like I don't really trust things that I can't look at, and like I don't.
Well, I was going to ask about that actually, because I'm looking at your video here, and it's like you can't even look at this thing because it's shoved so deep inside of a USB port.
But the software running on it, you can go and look at, and like you can build one yourself.
Sure.
The board uses a 6mm process, and so like that can be made by pretty much every PCB manufacturer on the sun.
Yeah, the cheapest ones out there, it can do it.
Yep, and like because it's so small, I think like if you go to something like Dirty PCBs and order their cheapest service, you end up with like 100 of them for like $5.
Oh, because it's like 100 millimeters or something like that, or whatever the square.
It's like and they give you like +3 ± 2 or something, and so you end up with like a bazillion of them. And yeah, the people were saying like, there's no way a hobbyist could make something like a YubiKey. And I was like, I reckon I can. And so one weekend I got tired of people saying that it couldn't be done, and I did it. I created a device. I sat there. It was actually a really fun distraction because it was something I could do in a weekend. Like if you look at my videos and HDMI to USB, it's been going on for like 7 years or something now. These are long projects. Whereas the Tomu was like a project. I sat down, I did the schematic, and then I did the PCB, and I actually had to have them both up side by side at the same time so that I could like swap pins, because it's effectively a single layer board because one side has the USB pads on it, so I can't.
Oh, right, of course. Yep.
I can't use vias or anything because the vias would go into the USB pads.
Right.
So I think I get one trace on the top that I get through.
Yeah.
But it was kind of fun to play that mental puzzle. And
yeah, of course. So why did you choose the part you chose? The EFM32HD309.
And I searched for ARM microprocessors that had inbuilt USB and did not require crystals and required the smallest amount of supporting parts, and then went sort by price and selected the cheapest one.
We need a name for that move. I mean, that's a pretty common one. Yeah, that's good.
And like the part, like total in individual quantities, it costs between $10 and $20 to make. As a hobbyist.
The whole board.
The whole board.
Okay.
In individual quantities, ordering everything from DigiKey. And that includes like the PCB and the 3D printed spacer that you need and all this type of thing. And so that is...
Yeah, I was going to ask about the cases too, because it seems like this thing, if it's in the USB port and you didn't see it there, if you don't have a case around it, I would probably crunch it to death with the next thing I'm trying to plug in there. Yeah. So that's always the downside of those really tiny USB drives and stuff. Yeah,
when developing, I just fold over some paper and shove it in to make sure it has strong contact. But you can 3D print a case. And so, yeah, I built the hardware. The problem is that then it didn't do anything, right? And so I got a whole bunch made and I started giving them out with the hope somebody would write some cool firmware for it. And a guy in Thailand and a coworker both did some cool software for it. And so a big thank you goes out to Josh and Sergey, who actually implemented FIDO support for the Tomu. And so you can actually use it like a YubiKey as a two-factor authentication device for things like Google and GitHub and anything that supports the FIDO standard.
What is the FIDO standard? I don't know that one.
It's a U2F standard.
Fewer acronyms.
Universal two-factor, I think, is what the U2F stands for. Basically, it provides a crypto challenge when you log in and...
got it, okay.
Like the token type things.
Yeah, right. Like the RSA tokens are the old ones I used to have that has like a time-based code that it gives you.
Yeah, FIDO, I believe, is a standard for that. But again, I'm not a security person. I would not say that the Tomu is a secure device. It is literally just an off-the-shelf Internet of Things device. It has no, hardware random generator or crypto storage.
Yeah, there's no crypto module.
Or anything like this.
Right.
But I actually believe that's a good thing because it's also very unlikely to have a backdoor to steal crypto keys because it's not designed to store crypto keys. And so it's as secure
it's still some small thing you're plugging into USB port that, you could have malicious code on there, but at the same time, I plug in keyboards and mice all the time too, so it's
what the code on there is what you put on there, right?
Sure.
And so...
Right, if you go and flash it right before you plug it into your computer, yeah, of course.
Yeah, and you can put whatever you want on it. An example I was thinking of is maybe it only responds when you tap your name in Morse code on it, or something like that, right?
Got it.
There's no... You could do whatever you want, and I would not, if I was the Dalai Lama or the President of the United States or something like that, don't use the Tomu as your security factor authentication. Please do not. If you're a high-value target, do not. But for my mum, who is going to get phished by, Nigerian prince scheme. Actually, it's more likely my dad. My mum's actually pretty tech savvy. My dad getting phished.
We all have someone in our lives that are they're gonna get phished at some point, right?
Yeah, this helps prevent that happening, and we can improve and iterate on the software again. If somebody wants to go and security audit that software, that would be awesome because it allows us to check where those bugs are. It doesn't the hardware we're not dependent on some hardware feature working some certain way for it to have. It's just software. And as I've been kind of banging on through this whole interview, software's really easy, right? You can iterate fast.
Yeah, let's just go breeze right past that one. But sure, yeah.
Yeah.
Software is really easy compared to certain things.
Easy to iterate quickly, let me say.
Yes, I do agree with that, yes.
It's not easy to get right, but, nothing's easy to get right.
Right.
And, one thing I try and say is, I'm a terrible software engineer, and I think everybody's a terrible software engineer. We all write bugs all the time. And the only way we're going to write better software is if people work on it together and actually work on improving it and help it trend upwards, improve it as they work on it and iterate on it and try new ways. Maybe, the current U2F firmware is written in C. Maybe that's a terrible choice. Maybe it should be written in Rust. And maybe Rust will make it so much more secure. But because this is a something. It's just an ARM microprocessor that you can GCC for. Somebody could write a Rust two-factor authentication thing for the Tomu and share it with people, and that would be awesome.
Yeah.
So
right, but yeah, okay, cool. So what else is on your list here? You had stuff about. Sorry, I lost the list too. So the Tomu though is funding still or no?
It's just about to open funding.
Okay.
So
cool.
I'm a busy person, and I didn't really have time to do anything, despite there being U2F firmware and designs and all that type of stuff. And lots of people don't want to make their own. And I love making hardware, but even I don't want to make my own most of the time. And so I emailed Sean Cross, Zobs, saying on the off chance he was interested. I totally expected him to say no. And for some reason, he said yes, I would be interested in taking this to market. And so I've basically handed over the project reins to him and made suggestions and stuff like this. But he's running the crowd supply campaign, and I have all confidence in him making that successful. And kind of
cool. Do you know when the date of that is, that it's opening?
It'll hopefully be open by the time this goes live. I think in the next day or two is when they're planning on launching it.
Perfect.
Definitely before linux.conf.au, because...
And when is that happening?
That's the 26th of January, I believe. Last week of January. Because, again... one of the things I strongly believe in is that open source helped me a lot and got me the high-paying job I have today, and so I want to give back to that community. And so we'll be giving everyone who's tending LCA a Tomu board to play with and do with what they want. If they're not going to do anything with it, hopefully they'll hand it on to someone who does, and that's kind of just a thank you to that community for supporting me as I grew as a software engineer. I don't think I would have had the job I have now if it wasn't for all the people who gave time to review my terrible code that I wrote as a kid, right?
Right. So you're giving a workshop at this though, about FPGAs and Linux and Python, is that right?
Yep. Lots of things happening at LCA this year. Looping back to FPGAs, again, lots of people are scared of FPGAs and scared of hardware. And I guess because FPGAs are kind of hardware, they're scared of that. And so at LCA, I'm running a day-long tutorial where I'm walking people through running Linux on a FPGA using a completely open source softcore, and the basically configuration of this system is all done in Python.
Oh, interesting. So what is that called? What's the softcore?
The softcore is OpenRISC-1K, but the Python framework we use allows us to switch between a couple of different softcores. So there's the Lattice Myco 32 and actually Clifford's Pico RISC 32.
Right.
And the OpenRISC-1K is probably your best choice if you want to run Linux on it. As you heard from Clifford's talk, the Pico RISC 32 is a good choice if you want to run your softcore in the same clock domain as your peripherals. And the LM32 is a kind of good choice if you want to run a bare metal type system. The LM32 is a very amazing soft CPU because it uses a astonishingly small amount of resources.
It's just like a real tight configuration within the FPGA.
And it has upstream GCC support.
Oh, interesting.
And so that is kind of why we use the LM32 in most of our projects when we're not targeting Linux, because of this upstream GCC support. And so
this is a Lattice softcore. The LM32 is a Lattice softcore, but you guys are using the RDA7. Is that right?
Yep.
Okay.
And we use
so there's no problem retargeting that stuff towards a Xilinx FPGA.
It's all released under, I believe, a BSD license. And so we can use it on any FPGA. And in fact, I'm pretty sure people have used it on Lattice stuff. They've used it on Altera, more Intel stuff. They've used it on Xilinx stuff. I actually believe Florent, the guy who does a lot of the LiteX stuff at CCC, got it running on the Ice40.
Cool, yeah.
And I
which
believe
is what Clifford was talking about. Yep.
Yeah, I believe it beats out Clifford's Pico RISC in terms of size on that. So we'll have to have a little bit more look, but it is actually a pretty awesome piece of technology. It's kind of sad that Lattice hasn't got any more recognition for this awesome thing they've produced. But
so tell me a little bit more about this flow too. So you're using Linux to implement these different softcores on the hardware, on the FPGA. Yep. But then, and you said at least the LM32 is GCC compatible.
Yep.
Do you then write C for it, and it's targeted with there's a port for GCC for it, or is it? I don't even know if that's the right terminology. But and then are you writing Python once again to actually target these processors?
So at LCA works explicitly running Linux on the softcore.
Okay.
So they will be writing C code that for basically Linux kernel drivers, for hardware they've designed in the FPGA during the tutorial.
Okay.
And so they'll design a little crypto accelerator and then write a Linux driver for it and do do some crypto acceleration on the FPGA as kind of like a demonstration of what you can do, and trying to make it less scary.
This sounds like a ton of stuff for a single day course.
We are going to have to gloss over a bunch of stuff, but it's not as hard as people kind of... if you have your software abstractions at the right level... you can get by without having to understand like all the minute details of how Verilog works.
Right. Okay.
Like
that's interesting too, because that is usually a tripping point for some people.
Yeah.
So you don't touch the Verilog at all. It's just all generated, or what?
Yeah. And so we have Python code that generates Verilog, and it actually generates C stubs and device tree as well. And so the idea is that if a peripheral moves, for example, or you add a new peripheral, these generated outputs, like the device tree, just gets another definition for the new peripheral automatically. And so it becomes very easy to iterate really quickly because you don't have to worry about like, well, what register location do I put this at? It just
right.
goes
I
in the
hard-coded this address, and now that the thing's not there anymore. Right?
Yeah.
Well, that's why people shouldn't hard-code addresses, but yeah.
Yeah. And so that's what we're doing at LCA, but we also have a project to, instead of running Linux, running MicroPython as the firmware running on the soft CPU.
Oh, interesting.
And so in that case, you'd be writing, instead of writing Linux drivers, you'd be writing MicroPython code.
Interesting. And so that's just a little bit more accessible because you're mostly Pythonistas.
Yes. And there's actually...
And so they're used to that as a way to then toggle I/O and low-level stuff, right?
Yeah, and a really, really interesting thing is we have these, what we call bridges that allow you to, on your host computer, talk to the Wishbone bus that connects everything together inside the FPGA. And so you can write Python scripts on your host computer that read and write registers for the peripherals you've created inside the FPGA. Now, with MicroPython running on the FPGA, in theory, you should be able to take the same scripts that you're running on your host computer and just run them on the softcore inside the FPGA, and they should do the same thing because the bridge is just basically gone now. Instead of writing to a bridge, you're writing to direct memory locations, but the API looks the same. It's still, write to LED 1 on type thing.
So the idea being that it could just be embedded somewhere without the actual tethering to a computer. You just write the code, turn the LED on and off every second or whatever. It sits within that softcore. And that's just a very simple example.
But you can do all your development on the host computer initially, where you've got your full IDE, you've got your full tab completion, all those type of tools that people like. You can Control-C it halfway through, all this type of niceties. And then once you got it right, you put it on the FPGA because, iterating quickly is much easier when you've got a much more powerful computer that you're using rather than trying. The soft cores are quite slow. They're talking hundreds of megahertz. You're even a cheap computer is,
say, Tim, you and I live in different worlds, but I know what you're saying relatively, but Okay, cool. No, that's a great use case. So what is all this? Are there names for all these projects as well that people might be able to look up?
So yes and no. I have a lot of projects, and so a lot of these things.
Maybe specifically for that MicroPython flow that you're talking about.
So we're just in the process of renaming it. It used to be called UPy-FPGA, but we realized we could name it FUPY. FUPY. So we had to change it to FUPY, right? Once you've realized that name exists, that's such a better name than UPy-FPGA.
Is it? I'm not sure. Time will tell. Maybe everybody will be wearing FUPY t-shirts someday.
Maybe.
Okay.
I think the real power of this thing is if you're doing a large-scale thing where you're, making thousands of something or hundreds of thousands of something, this isn't the right approach for you. But if you're doing prototyping, lots of us in the hobbyist are doing, we're making 1 to 10 of it, this is a really powerful way to work because it's a very productive and very quick way to work. And
I've actually been using MicroPython with one of the Adafruit Trinket M0s and just, basically, effectively peeking and poking with a serial bus,
Yeah.
It works great.
So the problem you have, though, is that's running on a real CPU, and if that CPU, if you need 4 spy controllers...
Right.
You can't do
that.
You
got to go redefine that the whole stack of everything, right? Because that's the board package that usually import in MicroPython. You probably have to rewrite that, right?
Yeah, but hardware, the Cortex Zero, probably doesn't have 4 SPI flash controllers, whereas in the FPGA land, you can just say, okay, let's just add 4 of them. If you have one, you can just add 4. And so it allows us to do a whole bunch of interesting things that maybe wasn't possible previously.
So that's a good example, though. So in that case, so you say so now you're targeting an FPGA. It's got the LM32 on it. It's got 4 SPI ports, like you're saying. Everything's reconfigured. It's using that device tree, like you mentioned.
Yep.
You do have to go rewrite some of the MicroPython code as well, right?
No.
Well, really? Okay.
Let me caveat this with when we eventually get to that stage, it's very much the MicroPython, just like Linux, should see that there are now 4 SPI controllers and just provide 4 copies of the class there that you can like use. And that's something that doesn't quite work yet. But it does work with simple things like LEDs at the moment. Like if you define there to be 12 LEDs, MicroPython automatically exposes 12 LEDs. If you define there to be 2, MicroPython sees 2 LEDs.
So this is almost like at a driver level right now,
yes.
where the LED part is so the low level LED type stuff is good, but the higher level I2C interfacing, SPI, whatever.
Yeah, we just haven't gotten around to finishing that yet.
Got it.
And that's mainly because we've been concentrating on the Linux stuff, because I have to run a tutorial on that in 2 weeks, and so
right.
that needs to be finished.
It does grab priority at that point, huh?
Yeah. But I definitely want to get back to the MicroPython stuff, because there's just... Linux is a full operating system, and there are lots of places where Linux makes a lot of sense.
Sure, yeah.
But there are lots of places where it doesn't make a lot of sense. And Linux needs a large SPI flash, and it needs some type of DDR memory, and all these type of things, which pushes the price up of the dev board that you do.
Right.
Whereas the LM32 running on MicroPython should work fine on a Lattice ICE40 FPGA that
exactly.
is definitely small enough to run on that. And even if the LM32 isn't the right choice, maybe you're running the Pico RISC-32 on the ICE40.
No, that's great. I really like that, especially because we just talked to Clifford last week. That's a nice kind of point of if you're on the ICE40, you're using a Project Ice Storm, you can build all that stuff, you can target it, you can use one of these smaller processor cores, and then there's targeting it with MicroPython. That's kind of all the way through. That's very interesting. Yeah,
and all the language that is used to define that I have SPI. 4 SPI controllers, that's all Python based. It's not it doesn't take Python and convert it to hardware. That's not what it does, but it's like a templating language that lets you easily template out that I want 4 SPI controllers without having to go into the nitty-gritty details of what's inside a SPI controller and that type of thing. So it's actually quite accessible at a high level, but unlike the kind of... Vivado has a GUI that lets you do a lot of these type of things. You just drag in a bunch of these things and connect them up with lines and that. You don't get any of the source code for that. That's the Xilinx tool if people don't... The Xilinx tool if people don't know what that is. The Xilinx FPGA tool line. Their new fancy one.
Right.
But the problem is, if you find a bug in the SPI controller, maybe you don't have the skills to fix it, but maybe you do, and maybe you want to fix it, and then you can fix it and send us a patch, and we'll include it, and then it's fixed for everyone. Again, the power of open source is having this kind of continual improvement, and why I want to continually iterate and improve things is this, when you fix a bug, we shouldn't have to fix it in every single thing every time from scratch. We shouldn't be writing yet another I2C controller or yet another SPI controller. If there's a good reason to, sure. But it shouldn't just be because, I feel like it. You've got better things to do with your time, I hope. Well,
speaking of time, we are running out of it. Where can people find you at conferences? Because it seems like you're kind of bouncing around to conferences, and also where can people find you online?
Okay, so I'm pretty much on IRC all the time. For those who don't know, IRC is what us old fogies use instead of Slack.
It's like Slack from the old days, yeah.
Yeah, it's Slack before Slack.
Right. It's almost like Slack just replicated all of the functionality of IRC.
Yes.
With GIFs, though. With animated GIFs. I mean, come on.
Yeah, my client does all that Slack type thing as well. Anyway, on irc.freenode.net, on the Tim Videos channel,
You got your own own channel. Yep.
That's where I think we've got about 100 people in that channel these days. Just hanging out. People doing recording, all different types of conferences around the world and that type of thing. There's a bunch of people from the CCC group there. There's a bunch of people from DebConf and FOSDEM and a few other things. So, yeah.
Are you going to be at FOSDEM coming up?
Sadly not. I will be at LCA, obviously, because I'm giving the tutorial there, and I don't quite know what conferences I'll be at after that. But if you follow me on Twitter, I'll tweet when I'm going to go to conferences. It's just Mithro on Twitter as well.
That is the nice thing about handles. They usually stay the same place to place. So that's good.
Yeah, I got lucky in that it seems to be rather unique, or at least it was up until recently.
Got it.
And yeah, you could also email me. I try and respond as quickly as I can. If you haven't heard back from me after a week, please send me another email because you've probably dropped off the...
or send help, one of the two, yeah.
Yeah, one of those two.
Yeah.
But yeah, and like, I want to like reiterate is that if you contribute to my projects, and I feel that not having access to hardware shouldn't be what prevents you from contributing to my projects. Come along, help out, and I will figure out some way to get you hardware so that you can be more effective. Whether it's Tomu or Tim Videos or HDMI to USB or just recording conferences or any of these type of things. I very much love it when people are using my stuff to do cool and awesome things, and if it's going to cost, like, Tomu's a cup of coffee. If I can shout you a cup of coffee in hardware, then that seems like a pretty good deal for me, I think. So
yeah, that's great. Yeah. Awesome. Well, Tim, thank you so much for being on the show and sharing your projects and, being generous with the hardware too. That's awesome.
Yeah, and we only got through, like, I think about half of them.
Oh, really?
Yeah.
Oh, okay, well, we'll have to have you back then too. Yeah.
Oh, it was really nice chatting with you, and
same.
Thank you for having me on.
Talk to you soon.